All right, 7.6, solving inequalities. I can move you. All right, solving inequalities is very similar to solving equations. For example, if we had p plus 7 equal 13, okay, to solve that, we would do the inverse operation, which is to subtract, okay, so you would say, all right, p plus 7 minus 7 equal 13 minus 7. Okay, and that would equal, these two cancel, that would equal p is equal to 6. Okay, well, the process is exactly the same up to a certain point. Okay, there we have one solution that will satisfy or make that sentence true. 6 plus 7 is equal to 13 is the only thing that it could be. Okay, however, if we're solving inequalities, it's going to look like this. P plus 7 less than 13. Okay, so they're saying the left side of the inequality has to be less than the right side of the inequality. But the process is still the same. Okay, you're still going to do exactly the same thing that we did over here. P plus 7 minus 7. The only thing that's changing, instead of having the equal sign, we're going to have the less than sign, 13 minus 7. Okay, it still cancels out. Adding 7, subtracting 7 cancels each other out. P less than 6. The difference here is this, where I would let you just say, okay, the answer to the equation is 6, and you just circle 6. Okay, I can do that because there's only one solution, 6. All right, in inequalities, you have an infinite number of solutions. In other words, I can plug any number into this inequality that's less than 6, and I'm going to get a true answer. Okay, for example, if I plugged in 5, 5 plus 7 less than 13, 12 is less than 13. Is that a true statement? Is 12 less than 13? Yes, it is. Okay, well, I could actually plug in negative 10. Negative 10 plus 7 is less than 13. Well, negative 10 plus 7 is negative 3 less than 13. Is negative 3 less than 13? Sure it is. Okay, so that's the reason we can't just put the number 6, because in all actuality, 6 is not an answer to this. Here's why. If I plug in 6, 6 plus 7 is less than 13. Well, what is 6 plus 7? 13. Is 13 less than 13? No. So that can't be an answer. Okay? So that is not correct. That's why we said P has to be less than 13. Okay? Now, let's remember our inequality signs. Okay, let's review those for just a second. This is less than. This is greater than. Okay, now this is where the two signs we're going to talk about next come into play. We've talked about them before, but you have, that is less than or equal to. Then you have the other one, is greater than or equal to. Okay? So, if that equation that we talked about if that equation, p plus 7 is less than 13, actually was written this way, then that changes what my answer is. Okay, if I have that written, then that would give me p less than or equal to 6. Now I can include 6 as my solution. Okay, because of this right here, because of the little bar underneath it, that means the answer could be 6. Okay, it could be 6 or anything less than 6. Okay, now let's talk about how we graphing the solution to an inequality. Okay, graphing the solution to an inequality. All right, let's take the original inequality that we started with. Okay, p plus 6 is less than 13. We've already solved this inequality, and we know that p is less than, actually it's 7. Keep putting the wrong numbers there. Keep reversing my order. We already know that p is less than 6. So I want to graph that solution. I want to graph all the possible numbers for that solution. Well, how we do that is we simply do this. We draw a number line. On this number line, I'm going to have negative 1, 0, 1, 2, 3, 4, 5, 6. Okay, to graph it, I'm simply going to put a circle at 6, and then I'm going to draw an arrow for the less than to the left. Now, obviously, your number line could go on forever. Okay, but the arrow here saying that anything to the left of 6 is the answer is how you would graph that. Well, what if we had this? What if our original inequality was p plus 7 greater than 13? Okay, well that means that would be p greater than 6. So now it's going to look different. I'm going to start here and go a number line of 1, 2, 3, 4, 5, 6, 7, 8. Well, now it's going to look like this. The circle still goes at the 6. Okay, but the greater than means I have to go to the right. Okay, so this is the less than sign. This is the greater than sign. Anytime you have the greater than sign, your arrow is going to go to the right every time. Okay, anytime you have the less than sign, the arrow is going to go to the left. The line in the arrow is going to go to the left. Okay, now, let's look at those same two expressions, but let's say they look like this. Let's say our answer was p is less than or equal to 6. Okay, well the number line is going to look the same. Negative 1, 0, 1, 2, 3, 4, 5, 6. Okay, I'll even put a 7 there. The difference here is, yes, I'm going to put a circle at 6, but because of the line or the equal to, I'm going to color in the circle and then draw the arrow to the left. Okay? So it's colored in because of this right here. Okay? The circle must be filled because of that sign. Okay, so if it was like our other one, P greater than or equal to 6, then our number line is still going to be the same. 1, 2, 3, 4, 5, 6, 7, 8. Okay, I'm still going to put a red circle at 6, but now I'm going to color it in and draw it to the right. Okay, and that is because of that right there. I must fill in the circle there. Once again, inequalities will have infinite number of solutions. Okay, an inequality that we're dealing with right now. There are some inequalities that don't have an infinite number of solutions. They have a set number of solutions. Okay, but it's a totally different inequality than what we're dealing with today. Okay? So, that's talking about the different types of solutions, how we graph those solutions, okay, and the simple fact that you're not going to just have one number that's the solution. Okay? Let's get into, we talked just a second about it, let's get into solving them. Okay? Because there is one difference in solving inequalities. I won't get to it yet, because I want to go ahead and do some other examples before I get into that. Let's look at it. Let's say we have this one, negative 56. Whoa, well, I went everywhere. Negative 56 plus y is greater than or equal to 113. Okay? Now, in this problem, what am I doing? In this inequality, what am I doing mathematically? What operation? Addition. And what am I adding to y? Negative 56. So the inverse of adding negative 56 would be to do what? Subtract negative 56. Okay, so I'm going to subtract negative 56 so that's what you have. Okay, I was adding negative 56, and so here is what I added to both sides to solve the inequality. Okay, on the left side of the inequality, these two cancel each other out. Okay, that leaving me with y. Now I just simply bring down this sign, greater than or equal to, and this turns to 113. Change that to addition. Do the opposite of that, of the negative 56, which is positive 56. So 113 plus 56 is what? 169. So y is greater than or equal to 169. Okay, I'm not going to have you graph every solution. Okay? I'm not going to force you to graph every single one of them. Okay? Now, on a test, you will have to be able to look at something, and we'll cover this here in a second. You'll have to look at a solution or a graph and tell me what the solution is. Okay, we'll talk about that here in a few minutes. Right now I want to focus in on the solving the equations. Okay, let's see here. Let's look at number 27. X over 9. X over 9 is greater than or equal to 1/3. Now, your little brains have kicked in probably by now, and you're no longer the Christmas zombie brain, okay, or the Clash of Clans zombie brain, okay, or Boom Beach zombie brain, all right? And you started freaking out because, oh my goodness, that not only do they have fractions on one side, they've got them on both sides. I can't do this problem. Okay? That's what your little brain's telling you, just like when you see the words instead of the numbers and you have a word problem, you go, oh, I can't do this, it's a word problem. Okay? Follow the process. Okay? Follow the process. The process is this. We ask ourselves, what mathematical operation am I doing on the left side? What mathematical operation is x over 9? Okay, it's division. X divided by 9. So the inverse of dividing by 9 would be to do what? Multiply by 9. So I'm going to rewrite the problem with the multiplication in it. I'm going to take and multiply, okay, by 9. Let me do this. That's going to look bad. 9 over 1 times x over 9 is greater than or equal to 1/3 times 9 over 1. So this is the part that we added to each side of the inequality. If you do it to both sides, it's still the same inequality. It's when you start doing it, you change the problem. Okay? So here, on the left side, the two 9s cancel each other out. Okay, leaving me with x over 1, which is just x, is greater than or equal to, on the right side, 3 goes into 9 3 times, 3 goes into 3 1 time. Okay, leaving me with 1 times 3 on top and 1 times 1 on bottom. Well, 1 times 3 on top is 3, and 3 over 1 is 3. Okay, so what they're saying is this: x has to be greater than or equal to 3 for this inequality to be true. Well, let's check. If we check it and say the original problem was x over 9 is greater than or equal to 1/3. That's the original inequality. So what they're saying is I can plug in any number. What we've said is I can plug in any number 3 or greater, and I will have a legitimate or a true solution. Well, if I plug in a 3 here, 3 over 9 is greater than or equal to 1/3. Well, what is 3 over 9? 1/3. So is 1/3 greater than or equal to 1/3? Yeah, it's equal to. Okay? Well, let's say I plug in a 4. 4 over 9 is greater than or equal to 1/3. Can I reduce 4 over 9? No. But 4 over 9 is almost a half, right? Because 4 1/2 over 9 would be half. Okay, is a half greater than 1/3? Yeah, it is. Because 1/3, this right here, is the same thing as 3 over 9. We just proved that. Well, is 3 over 9 or 4 over 9 greater? 4 over 9. So it is a true statement. So that does check. Just like this one checked, that one checked. Okay, so it is a true statement. Okay. Now, let's say I had this. 3G is greater than negative 36. Okay? Once again, the process. What are we doing mathematically in this problem? 3G is what? Multiplication. So what is the inverse of multiplication? Division. So the process is divide both sides by 3. Okay? On the left side, 3 over 3 cancels, giving me 1. So that's G is greater than, on the right side, on the left side, 3 over 3 cancels. On the right side, I divide 3 into negative 36, which gives me what? Negative 12. So G is greater than negative 12. And that is your answer. Okay, now, here's the part that confuses. When you solve an inequality by multiplying or dividing both sides of the inequality by a negative number, you must reverse the inequality sign. When you solve an whoops, I left my n out of my inequality up there. When you solve an inequality by multiplying or dividing both sides of the inequality by a negative number, you must reverse the inequality sign. Okay, I'm going to do a very simple example to prove this to you, and so hopefully you understand what we're talking about. If I have negative 4x greater than 16. Okay, negative 4x greater than 16. Now to solve this, you follow the same process. What are we doing mathematically on the left side of the inequality? We're what? We're multiplication. We're multiplying. What are we multiplying by? Negative 4. So to solve multiplying by negative 4, I must divide both sides by negative 4. Okay? So these cancel. So that gives me x greater than negative 4 into 16 goes how many times? Negative 4 times. So if I just leave it that way, okay, if I just leave it just like it was a normal problem with, dividing by a positive 4, then let's think about this. This says x can be greater than negative 4. Okay? So x greater than negative 4 means negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, right? And so on. Those numbers are all greater than negative 4, correct? Correct? Correct. Okay, correct. Good. Thought I lost you back to Clash of Clans zombie brain again. All right, now, let's plug one of those numbers in. Okay, we can pick any of those numbers. Let's pick 2. Okay, so I'm going to plug 2. I'm going to take this and plug it back into my original inequality. So that means negative 4 times 2 is greater than 16. Negative 4 times 2 is what? Negative 8. Is negative 8 greater than 16? No. So that's not true. Okay? So, what I have to do then is this. I have to take this sign here and reverse it. So, x is less than negative 4. X has to be less than negative 4 to make the inequality true. Okay, now let's test that theory. Well, x less than, not equal to, x less than negative 4 would mean negative 5, negative 6, negative 7, negative 8, negative 9, and so on. Okay, well, let's plug that back into our original problem. Negative 4 times, we'll just say negative 5, is greater than 16. Well, what is negative 4 times negative 5? Positive 20. Is 20 greater than 16? Yes, that is true. So that is a true solution. So, back to our statement. When we solve an inequality by multiplying or dividing by a negative to both sides, then we must reverse the inequality sign. Okay? Now let's look at one that's actually in your book. Number 31 says negative 7s is less than or equal to 42. So I need to solve negative 7 times s is less than or equal to 42. Okay, how do I solve it? The solving process doesn't change on any of these. Okay, the only thing that really changes between equations and inequalities is you must include the inequality sign in your answer. Okay, now the way the back of the book does it is they'll give you some books, I can't remember if that's the way it is in this book or not, they'll give you, where we had a while ago, x less than negative 4, they'll say all real numbers less than negative 4. That's how they'll, instead of writing it like this, they'll say all real numbers less than negative 4. That's how they'll write it. Same thing. Okay, I want it like this. I want it x is less than negative 4. Okay, but some books, and like I said, I don't remember if this particular book does it or not. I know I have had it in the past, and students have come to me, what does this mean? Okay, that's what it means. It means all real numbers, they're less than negative 4. Okay, so that means you could have negative 4.1, negative 4.19. Okay, that would satisfy that solution. Okay, back to the negative 7s is less than or equal to 42. Okay, I'm multiplying by negative 7. So to solve the inequality, I must divide both sides by negative 7. That cancels, leaving me with s. Now, I divided by a negative 7. So I must take that and reverse it. Okay? Well, the only thing that reverses is what's on top. You can't reverse an equal sign. Well, you can. But if I reverse an equal sign, well, I reversed it. Okay? It still looks the same. So, is greater than or equal to negative 6. Now, please understand that when you reverse that negative sign, or reverse that inequality sign, it doesn't mean that you have to come up with a negative answer. In other words, if I do this problem, negative 7s is less than or equal to negative 42. Okay, well, I still do the same thing. I still divide by negative 7 to both sides. Well, that gives me s is greater than or equal to positive 6. Okay, just because we reverse the sign doesn't mean you get a negative answer all the time or an opposite answer. Okay, has nothing to do with the answer. The answer is still going to be the same. Okay? Now, what if I had this? I would divide by 7 to both sides. Did I divide by a negative? No. So that cancels, leaving me with s is less than or equal to 6. You do not reverse the sign unless you multiply or divide by a negative number. Okay, and unfortunately, it's just one of those you have to, one of those special things, special rules, whatever you want to call it, you just have to memorize it. There is a reason behind it. Now, if it's easier for you to remember, well, this is why we do it, then remember that. But I found in the past, especially at this age level or at this point in your mathematical lives, it's easier just to give you do this every time you do this. Okay? Now, just like we change all subtraction to addition. Eventually, you'll get to a point where you see 3 minus 4, oh, that's 3 plus negative 4. I don't have to change it. That's negative 1, so 3 minus 4 is negative 1. Okay? You'll get to a point where that becomes very easy, okay? And you'll see it, all right? Now, let's look at one where you multiply by a negative. And that would happen to be number 29. Number 29 says c over negative 8 is less than negative 17. Now, it has nothing to do with the negative on the right side of the inequality. Okay? Well, for example, go back to that one we just did. Okay, that negative 42 has nothing to do with changing the inequality sign. I would still divide by 7, s is less than or equal to negative 6. It does not change the sign just because that's negative. The only reason you reverse the inequality sign is if you multiply or divide by a negative. Okay, now, so this one here, c over negative 8 is less than negative 17. Okay, well, we're dividing by negative 8, so the inverse of that would be to multiply by negative 8 to both sides. Okay, on the left side, those two cancel out, leaving me with c. Okay, on the right side, I took and multiplied by negative 8. So that means I have to take this and reverse it. Now, what is negative 17 times negative 8? 136?
No, 136, just 136.
136. Okay, so C is greater than 136. And that is your answer. The process to solve it doesn't change. Just the answer, the inequality sign in your solution will change. And that is only when you multiply or divide by a negative number. All right, now, let's move to a little harder one. To be, or not to be, That is the question. 2b minus 13. Yep. 13 is greater than 9. 2b minus 13 is greater than 9. Once again, how you solve an inequality and how you solve an equation is still the same. This is a two-step inequality. Okay? Two-step inequalities means that I have to do this. 2b minus 13 plus 13 is greater than 9 plus 13. I have to solve the addition or subtraction part of the expression before the second step, which is multiplication or division. Okay, on the left side, the subtracting and adding 13 cancel each other out, leaving me with 2b greater than 22. 2b is greater than 22. So, to solve that, I simply divide by 2 to both sides. That means b is greater than 11. Did I multiply or divide by a negative? No. So the original sign that was greater than is in your answer. Okay? Now, let's say that problem was this. Negative 2b minus 13 greater than 9. Nothing changes. You simply do the same thing. Negative 2b minus 13 plus 13 greater than 9 plus 13. These two cancel, leaving me a 2b, negative 2b greater than 22. I do the same thing here. I divided by 2, so I divide by negative 2 to both sides. That cancels, leaving me a b. I divided by negative 2, so I must take and do the reverse of greater than, which is less than, and that would be negative 11. So you would get b less than negative 11 instead of b greater than 11. Because of the one negative sign, because of this right here, this changes. Okay. Now, last thing I want to talk about is back to our graphing. All right. What inequality does the graph represent? So, the graph there, the number line, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4. And then I have a filled-in circle on negative 1, and the arrow goes to the right. What inequality, so we're going to have, we'll just say x, doesn't matter. So we said a while ago, when the arrow goes to the right, what sign is it? Greater than. So we know that it's x greater than negative 1. Now, to finish the inequality sign, we look at the dot. is the dot colored in, or is it not colored in? Colored in. So that means it has to be x is greater than or equal to -1. Okay? Let's say it was just the opposite. Let's say they drew a number line, went -3, -2, -1, 0, 1, 2, 3, and they did this. Okay? Well, that's still going to be x. It's pointing to the left. The arrow goes left. So that means less than. And it's not filled in, so it's just less than -1. Now, I want to show you a little, and I want to do it really, I need to do this line a little better here. Hang on. Okay, if you will notice, the point on the arrow and the inequality sign, they're both the same. Just like up here, point on the arrow and the inequality sign, they're the same. Okay, so if you can't remember, well, it's going to the right, is that the greater than or is that the less than sign? Just look at the point on the arrow. Okay, your homework. I know it's been a long time since you've had homework. We're going 7.6. And we're going 15 through 38, of which we did probably 8 or 9, 10 of them. Time is all said and done. You may go. Just dress out and go in the gym. I don't know yet.